Guys, my name is Sergey and I'm a senior data scientist in well-known FMCG company Burger King Russia. And today I would like to tell you about a solution to the interesting problem of classification of comments in App Store and Google Store um, this particular application of this company. So users leave comments and in this video we will investigate only negative comments so that I mean this classification would be interesting to see in dynamics. For example, yesterday we had uh, 100 comments on this particular topic, and today we've got 150 comments. That means this topic is interesting and is a pain point, then we could do something to improve and to do to make a good customer experience. But what is interesting about this particular problem is that all the comments are in Russian, because this is Burger King Russia, and natural language processing is well developed and organized in English. uh, there is a good base, knowledge base, well, not knowledge base, but a base on which the models are trained. So we've got okay, what is the best thing to classify text? Of course, it is a transformer neural network, because it is proficient in sequence processing. But what is the common way to use transformer? What is the common way? You should use pre-trained model, and reinforce it with your specific sequence of words, which are sentences. So this is one interesting point. So I mean that if those comments were English, that wouldn't be much of a problem. But in Russian, we need to find those pre-trained models in order to make this transfer learning. So here we go. What do we have? We have this file, of course, file with labeled comments. Here we can see the column. Let's name the column. Created is the date where the comment is created. Content is the comment itself, and rating is the just a rating, from 1 to 5. We are interested in negative comments, so we use rating less than 4, which means 1, 2, and 3. Class name is the human-made label. Here is the just label encoded, the class label encoded. So let's take a look at the comments, and what do we see? Of course, we can see smileys, emoji. So in order to make the classification, we would need some pipeline of cleaning pipeline, right? Because why do we need, why cannot we just put all the stuff into transformer and let it do the work? Why? Because if the word is not meaningful, then transformer will not be able to catch the uh, meaning of the word and meaning of the whole command, right? And speaking about smiley, you can put it anywhere. You can we can even see the commands consisting of or only from smiles or only from emoji, and it doesn't contain any information signal. So what I mean is we should make the pipeline of cleaning of the text in order to get rid of all uncommon and not meaningful words. And what I'm doing now is I'm trying to point out what are the examples of not meaningful words. Simple example is the emoji. Um, the other example I would like to raise attention to is the swear words. Swear words, which are not meaningful, but for some reason I cannot see it. Okay, I will find. Here it is. Here it is. So here is the command. For example, what is interesting about it? It is very short, and one word of this command is a swear word, which is not meaningful, of course, because we can put it in any position of any command, and it won't, change any meaning. What it will do, it will bring some stress. So stress. So we can consider it as punctuation, something like the exclamation sign or maybe some dots. Um, Same with exclamation and all those punctuation, all those question marks. They are not meaningful. We should remove all of them because they don't carry any information, and we cannot leave them here. We should, um, leave only the corpus of text in which all words are meaningful, and furthermore, they should be in the constant form. All the words like went, uh, go, goes, it should transform into one form, go or walk. And the same thing about, maybe not the same, but another thing is that what will happen if we clean this particular command, which I'm pointing out. We will clean all the punctuation, and we will have three words. One of them is with a mistake. With a mistake. The first word means sometimes, but sometimes is containing another letter. It is O. It should be O, but it is A. And we should not have this word in our corpus, in our final corpus, but maybe we should have the word sometimes. Maybe it's meaningful. And for example, if there are many words sometimes all across the corpus, and here it is sometimes with a mistake, then we will need to have the mechanism to replace this not that meaningful, not maybe not that frequent word, to replace it with a frequent word with its synonym. But anyway, it doesn't matter if it is frequent or not. It doesn't matter. if, for example, some weird example, people always write this word with the same mistake. It doesn't matter. We can, replace all the correct written words sometimes with the mistaken written words sometimes, and it will bring us the desired outcome, because we will reduce our um, number of our tokens. So what I would like to point out is why do we do this cleaning, and what we will have in the end of this cleaning. We will have the corpus of words uh, which are our we can think of them as variables, and we can think about these commands as equations which contain these variables. And this is our target, uh, our target. So this is equation. This is the right hand side of equation, left hand side of equation, right hand side of equation, and those are the variables. So what do we know about variables? They should be their count should be less than the count of our equations. So we can see that we have 2,345 equations. That means that we would like to have the number of our words in our final corpus less than 2,000. Otherwise, it will be any model we'll build, it will be biased. Maybe it's everything I would like to tell you about prerequisites of these tasks. One more thing that I would like to tell you about is that we have numbers inside of our initial corpus, and we would like to get rid of them, because maybe they can mean different things. I mean, depending on the context, we would like to get rid of them, but we've got some other constraint to this task. Constraint is some key words inside of this corpus. What are the key words? Burger King has coupons, which are named like burger for 1 ruble, or combo for 399 rubles. And if we got this keyword inside the comment, what does it mean? It means that the client is trying to point out that there is something wrong with this coupon, and we've got a particular category, coupons. So we would like to know that even if the comment is quite short, but we would like to know that it is connected with this category. But you understand that. Let's take a look at the names of coupons, and try to understand that there is another problem. which can be described as long name of the coupon, long name. That means that the client in the command can get rid of maybe some words of this coupon and maybe write some word with a mistake, right? Um, and we will need to have some mechanism to deal with it. And maybe with mining of these coupons, maybe I'm done with the overview of the task. So once again, we have the file of pre-trained, maybe not pre-trained, file of the manually labeled comments. Their number is 2344. And class name is, if I'm not mistaken, 15. Okay, here it is 14, but in the final configuration there are 15. What would we like to do is to understand how much is that. Okay, if we think that there are equal amount of comments per class, um, let's understand how many entities per class do we have. We can see that 155, and this is with our assumption that they are balanced. That data set is balanced, but of course it is imbalanced. So I would like to point out that even that 150 entities uh, is not enough to train the model from the scratch. So this is the point that we are using the pre-trained model. We'd like to use the pre-trained model. Okay. So I'm done with it. Let's go to I would like to introduce the final solution. Without digging deep. I will stop at some interesting points and all the information like where did I get this, where did I get that, I will put in the description. So I will have the bunch of URLs with a description of the mechanism used in the algorithm which I'm presenting. So let's dive into it. So here it is. I'm showing the Python notebook, which does the pipeline. Um, Pipeline of cleaning of the text, and when the outcome of this pipeline is the cleaned corpus with with the class and date and the ID of the command, but it doesn't matter. So what we would like to do is to clean. So we will need to add another column, which will be like cleaned command, command clean, which will consist only of the tokens which are their number should be less than 2000, and they will need to be in some particular form which I described earlier. There will be no punctuation, there will be no emoji, no swear words, no or almost no short comments, but I will tell you about it later. and maybe I will tell you about it now. What do we do if um, if the comment becomes too short? Too short. Um, uh, Maybe we need to make a decision to get rid of it, but we need to somehow classify it. Maybe randomly assign some class. No, it is nonsense. We will do the following. We will clean this command from punctuation, and if it is if the length of this command after punctuation and emoji cleaning is greater than 0, it contains something, right? Uh, then we will put it as it is into the transformer. And if it does random, then it does random. But what I would like to point out that we have this class name other. And how does it work? How will it work for transformer? Somehow it understands that if he cannot classify command as something like other, he puts it in other, and it will work the same for short command. If if it consists from only one letter, a transformer will not be able to classify it like something other, like other. I mean, something not in the category named other. Then transformer will put it, assign the class other. That's how it will work. And maybe short comment will consist from the something like the name of the coupon, and then it will be able to assign class coupon to it. So let's go back to the notebook. First input is just import of libraries. Here we import stop words. My stem is the lemmatization engine from Yandex. Punctuation, we will need to remove punctuation. What else interesting do we have here? Maybe nothing. The next input is dealing with the swear words using something. Oh, fuzzy search. Fuzzy search is not strict search. Not strict search is implemented with the library fuzzy. This fuzz it will deal with one word, and process it deals with compare one word to the vocabulary dictionary. Other thing that I am using is the obscene words filter. What it is? It is a library which has the URL GitHub reference here. It is just using how it is called regular expressions to find all the combination of the obscene words inside the sentence, and it masks it with stars. It is not very efficient, but I left it here. And what else did I take from here? It has a good vocabulary, which contains of some compressed swear words, and when it contains these letters without space, that means that it is an option. So you take this word, the first letter, second letter, and first of this. Then first, second, and second of this. First, second, and third of this, and etc. Until you reach the end. This is a compressed vocabulary, so I use it for fuzzy search later on. And here I implemented the fuzzy search, how it is done. So first of all, I use iter-tools to iterate over all of over this compressed vocabulary and make the long vocabulary of Russian swear words, and it is written in the variable named obscene. And when what do I do in the function named swear2? Swear2, there was a first version, swear1, but it was not efficient. So what did I do? What do I do here? I iterate over obscene words and calculate the probability that this particular word, this phrase 0, it is a word. It is a word in lowercase. And what is the probability that this particular word in lowercase contains the our obscene word, right? So iterate through obscene words, and if the probability is greater than 75, then I return 1. And it gives us the desired output. So here it is. Here is the example of usage. Just we put our obscene words and our desired word. What we would like to do is to deal with obscene words written with mistakes. Here is the swear word written with many mistakes. Here is a swear word, right? And it marks like a swear word. Let's experiment with it. Let's mask some particular letter with asterisk. How will it deal with this? You see that this function marks it as it is non-swear word. The probability is less than 75. Then, what do we have to do in this case? And why is that? Because this fuzzy search deals with the distance of the letters, and asterisk is very far from the letter E, which I deleted. So what we would like to do is to get rid of the asterisk, and then we will get this desired output. So our strategy is to remove the punctuation first, and then make this obscene words filter afterwards. Here we input our corpus. We can see that it has 15 labels. It is not the same file that I showed you, because one category was added to it. But what I would like to show is that even if I try to balance the classes, you can see that this class loyalty has 300 entities, and this comprise class has something like 116 entities. So it is 3 times great. So the classes are imbalanced, and you understand that we should, drop uh, drop these entities in order to make everything be like 120, and we will get rid of 2/3 of these entities in the loyalty class. It is unacceptable. And I will show you how I dealt with that and how I got good accuracy. So what do we do next? Here we load coupons, and this particular input is very sophisticated. It deals with I will show you. The main function is clean comments. It take comment as an input, that it removes emoji. Here it finds the substring, which is similar to coupons, one of the coupons, and replace the complex thing is to not only to understand that the phrase likely contains the name of coupon, but fuzzy wuzzy library doesn't allow you to extract the token, which I mean, not a token, but a sequence of words, which fuzzy wuzzy thinks that it is likely a substitute for our candidate, right? In other words, you can get the probability number that it has this, the probability that the string has this substring, but it doesn't point out which substring is which substring of our string is like the substring we are trying to find in this string. I explained it very quick. So we need to make some procedure, some function that extracts, I mean, manually make the procedure that extracts this substring. and replace this substring with word coupon. What we are doing next? We've got some replacement dictionary, what it is for. For example, this word is uh, like drive, right? Um, like drive or food in Russian. And the MyStem library will likely deal it as drive. Why is that? Because drive is more frequent. It is the okay, of two words, food and drive. Drive is more frequent in Russian language. Then it will uh, deal it as drive automatically. But in our specific, we are FMCG. Uh, we do not drive. We are dealing with food, so we need to explicitly point out that this form of the word should be considered explicitly as food. That's the point. And some other replacements are done by the same reasons. So we just understand the frequent words that has not okay. We are just we are correcting the mistakes, probable mistakes. Here it is to cry and to pay. And this word is in this case we should deal with words as pay, of course, not to cry. And even if it is cry, we would be better mistaken and take it as a pay than cry, because cry in our case doesn't mean anything. For example, Burger King, we are not as subtracting, but we are replacing with BK, just because we would like to, have one word. So this is for reduction, and this is for mistakes correction. That's the point. This is for coupon. If we have this, without this is the name of coupon, and if user has written it without mistakes, then we will rename it as coupon particular. If it has something with mistakes, then this rule would not work, and what will work is the further coupons processing mechanism which I described earlier. Maybe it is interesting to tell you about the mechanism which is finding the needle in a hay, what it is about. Here is a reference URL to Stack Overflow, which I have taken it from. It is dealing with extracting of some n-gram, which is some sequence of words, which is likely a token which we are trying to find, which fuzzy marked as a token which we were looking for, but it didn't tell. didn't tell us. Fuzzy Wuzzy says, with a good probability, there is some token somewhere there. And this procedure is telling us what is the prob probably what is this token and what is the probability. So it is dealing with n-grams, and input is the here is a comment, and here is the coupon name which we are looking for, and it takes similarity score, and we don't have the constraint on the upper value of maybe lower value. Upper value is 100. We don't have constraint of the lower value to lower value, lower threshold. So we already know that there is the word in there. So the string of code which finds our substring is here is number 54. It is SM. SM is, let's take a look what is SM. SM. I can't find it. Can't find it. I can't find it. So it is somewhere here. Maybe I should just here it is. Sequence matcher. So here what it comes from. dflip sequence matcher. That's how it works. Let's go back to what I was talking about. Actually, we are far enough. So let's get back to our clean command. So what does it do? Eliminate emoji, then find substring and replace it with coupon. I mean, it is coupon processing. Then replacement dict, which has two purposes as I described earlier. First one is the mistake correction, and second one is the using most appropriate form of the word we would like to have in the final purpose. Then punctuation replacement. First of all, I had this some punctuation I replaced with nothing, and some punctuation I replaced with a white space. But then I understood that it is better to replace everything with a white space and then replace duplicated white spaces. Why is that? Because some users, they put word, then exclamation, then another word without a white space. And in this case, we get these words which are bound together. We don't need this situation, so it is better for us to replace everything with white space and then remove duplicated white spaces. Here we use these regular expressions to get rid of the swear words. In this string we get rid of swear words with a fuzzy search, and this is stop words elimination. Stop words is just a dictionary. And here we added some words to this dictionary and we removed the word uh, uh, short word not because uh, not good is different from good, and if we so we need to distinguish one from another. And how do we deal this not? We will replace not. Okay, if we think about the phrase "not good," will we would like to have one word instead of it. Not good. We would like to, have one word not good and replace the white space with this symbol. Why with this symbol? Because when we load it into transformer understand this sequence not good, and when we put it into transformer, we would like to um, bring back our white space, but in order to do this, we should make our this underscore like a keyword and delete it from punctuation and delete as a keyword. Okay, so in our final corpus we will have these words like not good, not working, and etc. The combinations of the word not and some other word which is meaningful to us and brings and has some information signal. Where we were. We were here, Russian stop words and swear words. So we clean our corpus from, clean the comment from Russian stop words and swear words. What next? We are dealing with this underscore once more. There was lematize. Okay. Here we use this Yandex lemmatization. Lemmatization converts our words into some particular form, into some form. Okay. Into some equal form. So all the words will be in equal form, but it does some other stuff which we don't like. It is getting rid of our underscore and some other transformations we don't like. So we need to bring it back, and here we're bringing it back. And then we are getting rid of short words. Short is like less than 2. less than 2 is 1. Okay. And then we are getting rid of short comments. So if it has one word, we are putting nothing. And afterwards, after everything is done, what we will do is we will get our initial comment here without punctuation and end in lowercase. We are almost done. What is left? What is left is okay. Here we are applying this function, clean comments. This is normal warning from fuzzy. It's okay. It's okay because it is dealing with a command which is too short. For example, here it consists only from 3 dots, and fuzzy says that I don't know how to deal with it. So this input deals with tf-idf. Tf-idf. Okay, up to here, we've got our tokens, but we will need to reduce their number to less than 2,000, and we would like to use tf-idf, which deals, if I would explain it simply, in a simple manner, it deals with remove too frequent words, which is used everywhere, and remove words with almost zero frequency. And this operation executed simultaneously will leave us the desired corpus. So what do? We just import tf-idf and transform, and then we are doing some weird thing. We have got our 2,300 something, you remember, comments. And the weird thing is that we are making tf-idf on each word. So we will have the table with row is a comment, and the columns are tokens, set of our tokens. And then for each token we calculate this tf-idf, and what we are doing is we are summarizing value of this calculated tf-idf for each token by each row. We are calculating the sum of these token values for each row. You understand that if we have 2,000 rows, the value may be 1. Sums up to, okay, maybe not 1, 0.8, right? And if we have 4,000 rows, it will be 1.6. So we need to, in further calculations, we need to understand that we need, we can only apply this filter when we've got something like 2,000 rows. So we are summarizing and we are applying this threshold, and you see how we do it. We just summarize, and we are saying that everything that we need everything that is greater than our threshold. What's the reason that I'm doing such strange thing? The reason is that it works well. It works very well. It is okay. Maybe 2,000 is 2,000 comments is not enough to do this tf-idf. I'm not sure. So this is the point this is the point why this particular transformation works very well right here. So it is just the way I'm dealing it. So it is not the common way. What is the best way here? It is verified by my eyes. And also we leave this word SMS because it is short but it's meaningful. And we are getting rid of too short words that are too short. But we leave the word SMS. And after analyzing, we are analyzing just with our eyes. We see that we can add the stop words with this list and get rid of them, of course, because they are not meaningful. And we couldn't see them before because there were too much words. It is just doing this operation. After all, we are looking at the final list and we see these words and we add them here and do this again. This is how it's done. But in the so how many tokens are left in the final corpus? 1,800. It is less than 2,000. It is okay, but we should understand that it contains synonyms. We should get rid of synonyms, but how do we do that? Very simple, using fuzzy search. Fuzzy search. So we iterating over our terms, and for okay, we use pop method gets the list element out of the list. And for the rest of the list, we iterate through the rest of the list, and also pop the elements which has the similarity score more than 88, and we consider it synonyms. And we are making the dictionary which looks like that. Here is the word and here it is synonym. After that, we are just doing the following thing with the command. If okay, we iterate through each words in a command. If it is in our token list, then we leave it. If it is if it is not in the token list but it has the token as a synonym, we put a synonym here. If it is not, we are deleting this token. And we are done with this pre-processing. We are done with this pre-processing. The other thing, the only thing left is to do this function named clean short, which cleans the punctuation from the command and leave and do it lowercase and leave it as it is. And replacement dict, of course, because it doesn't delete anything, it just replace. And we are done. We are saving our file. Our file is saved like in the following format. It has clean txt, which is a list. Here it is, one word. Class name is other, and we've got the text. Text is the list elements concatenated with the white space. That is all. Interesting that it is in English, not in Russian, and it is named as other. So we are done with this transformation pipeline. What am I doing next? What am I doing next is I'm using tiny-BERT, kindly provided by some guy from this post and from this GitHub repo. This guy prepared two scripts, BERT dataset and BERT classifier, which is doing the following. It is a data loader, and this class constructs the model from chopping out the last layer and training the layer with, reinforcing the model with our corpus and with our labels. That's the point. So I can show you in Colab how it is done. In Colab. Maybe here. It is just files. It is just files. It is requirements also provided by this guy. Here we load our file. Then we make some simple replacement. And then we are doing the following thing. We do the train val test split, and for train we need to balance the dataset, balance the classes, but not equal. Here is the printout of the value counts of the classes. Here we see that this minority class has 33 entities and the majority class has 90 entities. This proportion was verified manually. I understand this is 3 times bigger than this, but it works. It works okay. And I would like to point out that we are balancing only our train class, validation class, train dataset, validation dataset, and test dataset. Of course, it should be disbalanced as in reality. How do we use it? Very simple. Just we make our class, BERT classifier, with some inputs. Basically, where to store the model and the path to model RuBERT tinies is used, and here it is tokenizer also RuBERT tiny. Here it is the path where to save the model. Then we load data, and then we just train it for five iterations, and number of classes also we input. It trains. We can see that validation accuracy raises from 0.53 to 0.61, and here it is the precision 0.61. On test, recall 0.56, and F1 is 0.54, which is let's do a classification report. Classification report is F1 score macro is 0.61, and it is good enough. What I would like to point out is that this accuracy is lower than actual. Why is that? Because um, our clients are motivated to raise multiple questions inside one comment, and we are trying to bind them to one class when we are classifying them manually. And if a client raises 3 points, 3 topics, for example, price, loyalty, and delivery, and we manually we are saying that it is delivery, and the model is classifying it as price, then we put 0. Then model is mistaken, is biased, but it is not. So we should use another metric, but we are doing it fast. So we are using this F1, and F1 is 0.61. It is good. And if you look over these comments, you understand that this quality is enough. It is like near human level performance. It is near human level performance, which is quite remarkable with, let's see, which frequency, which number of examples did we have? 33, 33, class 5, 33. Class 12, 90, 90 is less than 100, is nearly nothing. It is, of course, not enough to train over all of these tokens, but pre-trained BERT model does this magic, does this miracle. It was trained, by the way, on Peekaboo comments, thanks to Sberbank, thanks to Peekaboo, and it performs like human level performance. Very cool, very cool. And the last thing I would like to maybe not to point out, but to just to show how am I implementing this model. If I'm not mistaken, this one. So I implemented some class, or maybe not a class, maybe just a code. Just a code. Where it is? Here it is. What does it do? What does it do? It has procedure named pre-process commands, and the procedure which what does it do? It takes all the commands, all the new commands, but you can see to 2,500. So this is for that, as you remember, for that threshold of tf-idf. My weird processing of tf-idf may be implied by not enough samples, I don't know, but it works very well. So I take more samples that I need, then I do this tf-idf, and then where it is, I need to know. There was, here it is. So I process all of them, and then take only comments which are new, Um, just I need to point out that this procedure contains two modules implementation. One model is this one, BERT, and this model is BERT2. Why is that? Because other classes, there are 15 and here are 14, and we would like to make both classifications, store the result of both classifications. this preprocess commands is the pipeline which I started with, and assign class is a simple procedure which takes the model. Here it is. It is the model. Uh, model name, right? Model takes the model and just make predictions. That's all. But you see, as you can see, they are pre-processed with different files. So we load some file with which was labeled, which we trained on. It contains our corpus, and we use synonyms only from this file for this particular model, right? So it is the other file with other synonyms, synonyms. And after all, when we get this res data frame with review ID, this is comment ID, and class name 1 and class name 2, then we write it down to our database. That is all. That is all. So briefly, we ran through our task statement and our pipeline for dataset cleaning, pre-processing, notebook with model training, how we use the TinyBERT for model training, and after all, we finished it with something like production implementation, or something like production implementation of writing of scoring and obtaining the new commands, pre-processing them with some particular file of synonyms, assigning the class 2 times, and writing them into the database. And then we've got this, I cannot show, I'm sorry, the diagrams with the dynamic of each class, depending on time. Thanks for watching. Subscribe. I think that I will share some other videos shortly because there are many interesting tasks done. Thanks. Bye.